Alright, so this is section 6.1, the standard normal distribution. Here in this example we'll do some z-score conversions and practice that for a few case scenarios here. Like for this example, it says that the mean height of 15 to 18-year-old males from Chile from 2009 to 2010 was 170 centimeters with a standard deviation of 6.28 centimeters. Male heights are known to follow a normal distribution. Let x be equal to the height of a 15 to 18-year-old male from Chile in 2009 to 2010. So therefore, x random variable is normally distributed with, again, the two parameters there. The mean is 70 and the population standard deviation is 6.28 centimeters here, illustrated here and in this notation. The same notation for the bell-shaped curve. And again, that's going to iterate as well with the language when it says follows a normal distribution. And this is just iterating that with the letter, the N in that description. Suppose a 15 to 18-year-old male for part A there was 168 centimeters. Calculate the z-score for that individual. So sorry, there's a typo here that should say interpret. And not the word internet. Alright, so then pretty simple here. You're going to take that value at hand. So this is x for the 168. Subtract the mean from that, which is 70. And then divide by the standard deviation. Okay, let's go ahead and grab a calculator, order of operations for that. Then we'll discuss about rounding. So we've got the 168 centimeters to start off with, minus 70. Equals 98, and then divide that by the standard deviation, 6.28. And then we get 15.605095, which seems a little off. I think I have another mistake there. Yeah, I do. Alright, so I gotta correct this one then and change it for the problem. So here it is here. The mean is 170, and even though I was doing my math wrong, there's another typo I have here, so I may have to redo this one that should say 170 centimeters and not 70. Completely throws that whole problem off. So yeah, let me go ahead and correct this. Yeah, it's going to make it a lot, because to be at 15 standard deviations is pretty rare, in fact impossible. All right, let's try that again. So 168 minus 170 is negative 2. Negative 2 divided by 6.28 is negative 0.31847. We're going to go ahead and round that to 4 places, but I want to note that that is a negative value, indicating that the data point, or their height there in centimeters, is below the mean. 3185. So negative 0.3185. And so the last video that I did, I explained that the negative means that it's below the mean. So we are approximately 32 standard deviations below the mean. That's about, if you look at 0.32, it's about a third below the mean in counting those standard deviations of, if you were to count by 6.28. So that's for part A. And the one thing to note here that we're going to end up rounding these critical values or these values to 4 places. And that's also indicated on when we start going over and using the GeoGebra calculator. It'll also round that to 4 places as well, and then we consider that as a critical value. But just for all purposes, kind of note that that is, it's kind of like a third, or counting a third there, of a standard deviation below the mean. For part B, suppose that the height of a 15 to 18-year-old male from Chile from 2009 to 2010 has a z-score of negative 1.27. What's the male's height? So this one we have, and then just kind of discussing a few things. We know that z is equal to the data value minus the mean, then divided by the standard deviation. If we went ahead and solved for x by rearranging the values, what I would do is I would multiply both sides times sigma, and what that does is it gets rid of that division, the multiplication on that side. Then the last thing that we want to do is go ahead and add the mean to both sides, and that gives us an alternative formula here that we know that in this case x is equal to sigma times the z value plus the mean. So there's a formula that we're using to make a z-score conversion, but in this case we want to use this one because we're given the value z for z. So we're given z, solve for x. Okay, and that's what we want to do here. So we don't know what x is, we don't know what the data value is, but this would be equal to, here we know that we have negative 1.27 for z, and we want to multiply that times the standard deviation, which is up above is the 6.28, and then add the mean, the 170 centimeters, to that. Order of operations, of course, what we want to do, multiply and then finally add to come up with that answer. So let's go and do that. We'll take here the negative 1.27 multiply that times 6.28 and then plus the 170, and we get 162.02 centimeters. When doing that conversion from z to a data value, there isn't really a set rules there on that, particularly because we probably don't know what the data looks like, but I just want to indicate some of the formulas there with that. So alternating between part A was solving for the z-score, and that was x minus the mean divided by the standard deviation. But if you flip it around back the other way, then we have to do directly the opposite there. If we given the z value, in this case we're given that number, we want to solve for the data value, and what we do is we do a reverse formula down here to apply to do that. So that ends it there for this example with finding the z-score and the height for a 15 to 18-year-old boy or year-old male from Chile.